physics says about evolution. First of all, physics can date fossils. Physics can tell you how old fossils are by looking at the residual radiation in fossils, and thereby we can construct a tree of how different fossils have changed over time, because we now have a yardstick, a clock, by which we could put them in chronological order. And we do see a pattern. We see tree-like limbs, just like the way Darwin predicted. And another thing that we can do in physics is give you the mechanism that makes this possible, mutations. Darwin could only dream about why one species turned into another. Now at the atomic scale, we can see the effects of cosmic rays. We can see the effects of random mutations of DNA molecules. We can see the effects of chemicals. So we now have a physical basis to why animal species will mutate from one form to the next form to the next form. So these two things, first, being able to date the age of all the life forms on Earth, and second, a mechanism that gives us an explanation of why this takes place, gives us a pretty good theory of evolution.
Dr. Kaku, when a star collapses to form a neutron star, the result is an incredibly dense object with a defined diameter. Does all the matter inside a black hole also have a diameter? I've heard a black hole referred to as a point source, but can't get my head around the idea that all that matter can shrink in an infinitesimal size. Can you help clarify this? Robert in Cape May, New Jersey.
Well, that's the $64,000 question. What happens when a black hole collapses to this dot? First of all, when matter collapses, we have to say what is retarding or resisting that force of collapse. When a star collapses to a neutron star, there's neutron pressure. There is pressure of neutrons pushing against each other, and that's why neutron stars are stable. But if you collapse a neutron star, what's left? What is there left to prevent the star from collapsing to nothing? And the answer is nothing. We have no known force that can withstand gravity on that scale. However, we do think that when a black hole collapses, it doesn't collapse to a dot. It probably collapses to a ring. That's what the math says, because these things are rotating very rapidly. And if you have a vibrating ring, a rotating ring, then at the very center, you're not going to die necessarily by going through. It could be, in some sense, a gateway to a parallel universe. Then if all the matter falls in and comes through the ring, then where does it go? If it comes out the other end, then it looks like a white hole. So there is a theory, not believed by everybody, but there is a theory that says that as everything falls into a black hole, it goes through the ring and is blown out the other end as a white hole. In fact, there's some physicists who believe that that's the Big Bang. Why is it that the Big Bang is spewing material out in all directions? Perhaps we're a white hole, and on the other side of the white hole, there's a black hole.
Chuck, Tampa, please go ahead.
Yeah, hi, Dr. Kaku. I'm a huge fan of Sci Fi Science, and for the longest time, I've always been fascinated with physics and how the world works. And I was just wondering, well, for a time, I have these ideas and thoughts that I just think of, and, a couple years later, it'll kind of put itself together with the way the physics work. But I was just wondering, how do people like me who, we have a lot of imagination, but we aren't physicists per se, so we can't crunch the numbers on stuff. How do we get our ideas out there? And, maybe one day they would actually sort of, come together.
Hey, Chuck, are you a student?
Yes, I'm a student at FSU.
Oh, okay. And what are you studying?
Right now I study theater.
You're studying theater, but you have physics ideas.
Yeah, I've always been extremely fascinated with physics and with astronomy. I just have a huge curiosity for the way everything works, but I just don't think I'm really smart with the numbers.
All right.
Okay, I get a lot of emails from people saying, I have a theory, or I have an invention. What should I do with this? First of all, if you have an invention, get a patent attorney. Get it patented. If you think it's good enough to survive in the marketplace, hey, maybe you could be the next Edison. Who knows? Get a patent attorney. Start to think about getting a patent. If you have a physical theory, you think you're better than Einstein, or you have a new insight into black holes and exploding stars and things like that, get it published. You can write to the various physics magazines that have referees. The referees will then look at your work and then try to pick it apart or maybe vindicate what you're doing. If, on the other hand, you just have a general idea, an idea without mathematics, so you cannot be submitted to a journal, then, of course, you can publish on the web. Lots of ideas are on the web. It doesn't guarantee that it's going to get a lot of readership, but at least you can get it out on the web. So for people, however, who are serious about this, you do have to, at some point, confront the math. That's what separates the amateurs from the professionals. The professionals can then be very precise, be very exact, make predictions from this idea. But again, if you don't have the math, you can always publish it on the web and then invite people to take it apart or go on blogs. Some scientists, my colleagues, have their own blogs, and you can earn the attention of other scientists and other learned individuals by writing blogs on the website of a scientist.
mkaku.org is Dr. Kaku's website. Do you have any patents?
No, most of what I do is purely theoretical, and we don't have enough energy to create any of the machines that I write about in my books.
All right, Barrington, New Hampshire, almost out of time. Please go ahead.
Dr. Kaku, sir.
Yes.
I have one question. Well, actually, I have about 10 to the 19, but I promise this will be one question, and it concerns gravity. I'm about 58 years old. I'm interested in everything that ends in ology, pretty much. But with gravity as one of the forces of the universe, all my life I have been concerned about or curious about what generates that force. And if I might, I'd just like to add.
You know what?
We're out of
time. We're going to have to go with just that question. Go ahead.
Okay, well, no one knows what generates gravity. However, we think that if space is like an arena, and we are subjects dancing on this arena of space, the arena itself could be curved. So the curvature of space immediately looks like a force. If you walk on a stage that is warped, it looks like someone's tugging on you. That, Einstein said, is gravity. Gravity is nothing but the curvature of space. The problem is when you quantize it, all hell breaks loose. And that's why we physicists have plenty to do in the coming decades, is to quantize the theory of Einstein.
Michio Kaku has been our guest for the last 3 hours on In Depth, and my head is swimming. Thank you very much for your time and for sharing your knowledge with us. Here again are his books. Beyond Einstein was the first one. Hyperspace, a scientific odyssey through parallel universes, one that he recommends if you're only going to choose one or two of his books to read. Visions came out in 1999. That's the other one he recommends, again, if you're only choosing one or two of them. Einstein's Cosmos, how Albert Einstein's vision transformed our understanding of space and time. Parallel Worlds, a journey through creation, higher dimensions, and the future of the cosmos, came out in 2006. And Physics of the Impossible, a scientific exploration into the world of phasors, force fields, teleportation, and time travel. His most recent, coming out in March 2011, is
Physics of the Future, about the world of the year 2100.
Thank you. Next month on this program,